So, welcome everyone to the second episode of Friendly Funders. So, today we have with us Srinivas Narayanan. So, he leads the Applied Machine Learning group at Facebook right now, which works on applying AI technologies to advance Facebook's products. So the group does research and development in the broad range of areas such as computer vision, natural language, speech, videos, and personalization. So he has led several efforts at Facebook, including create the interest graph, launching the location product, and leading engineering for photos, where he also helped start Facebook's efforts in computer vision and deep learning. Prior to Facebook, he was a founding member of two startups and was part of the database systems research group at IBM Alumni Research Center. He did his master's in computer science at University of Wisconsin-Madison and BTech in computer science at IIT Madras. So let us welcome Mr. Srinivas Narayanan for this session.
Thank you.
Yes, and we also have with us Mr. Mani Iyer, who has helped us to moderate the previous session also. So he is right now the CEO of Quansu, which is an adaptive account-based marketing solution provider. And he also, as many of you already know, he had come here to start this link between the alumni of various IITs who are, ready to help us connect with the alumni of various IITs and the current students of IIT Palakkad. And he is right now leading this session he will be moderating our session with Srinivas Narayanan. So he is also a graduate of, he did his bachelor's from IIT Madras, and later he went on to do his master's from same University of Wisconsin-Madison. So now let's get this session started right away.
Thank you, Josine, and thanks everyone. I know it's 8 p.m. in Palakkad, and we're glad to see you all taking some time here to meet with us and talk to us. We are, of course, going to do. Let me again explain the structure. We're calling it the Friendly Fundas videocast, and as I kind of shared with you guys last time, the core thing I believe in anything is the 4 words. I'm going to repeat it. Get your fundas straight. So I'm hoping you'll get your fundas straight on AI and machine learning. We're very, very excited about having, one of the guys who's the best in the business right here, who works at Facebook, Srinivas Narayanan. Srinivas, welcome.
Thank you. Hey, everyone. Really nice to see you all. And, hope to have a good session today. Hope you'll learn something from this, and don't feel shy to ask tough questions.
Yeah. So, Srinivas, we did this last time with Joy. I think that same structure is something hopefully the students find very useful. Can you kind of start out by telling us a little bit about your personal kind of, arc, if you will, starting from high school? Where did you go to high school?
So I grew up in Chennai. I guess now Chennai, then Madras. I went to high school in a school called PS Senior Secondary School in Mylapore in Chennai. I did high school there, and then I was always interested in science and math, and that led me to study hard for IIT. And as many of you probably who are sitting there have done before you came to IIT. I did all the, I think at that time we had Agarwal classes, and I don't think they exist anymore, but, so that's sort of what got me into IIT, right? And I was always interested in science and math.
Okay, interesting. And why did you look at different IITs? Or I guess Madras is close to home, so An
Yeah.
easy decision for you?
Yeah, I mean, I think it was honestly not a huge choice. Madras is one of the great institutes at that time, and so it was fairly easy for me to just make that decision. I didn't want to really go away from it. I mean, I would say, I mean, I was very interested in physics as well as math, and I briefly considered going to IIT Bombay to study engineering physics, but decided that I would just stay home where I grew up and study computer science.
Got it. So how was IIT Madras? Can you talk a little bit about your experience there through your undergrad years?
Yeah, it was wonderful. I mean, it's a very beautiful campus. I don't know if some of you might have been there. Very beautiful campus. And you know, it's a great institute. I think we have really great resources, wonderful set of students. I stayed in the hostel, and college days are some of the best days that you remember when you look back, right? So, a lot of intellectual debates on all sorts of topics, some important, some not so important.
Yeah.
But it's a great environment to just grow up, and I would say, very friendly environment as well, right? So yes, we all study hard, we all work hard, but you also have fun. So
Okay. Did you
yeah,
go for late night chais to Taramani like some of
yeah,
us?
absolutely, yeah. Late night chais to Tarams, not Taramani. Yeah,
Okay, there you go. I,
yeah.
I was giving the proper name for the benefit of the other guys there listening. So
Yes. We
okay.
had Quark. I don't know if you remember that. There was a right
Yeah.
back in the hostel. Quark was closer. Tarams, you get chai and appam. Uh,
Okay.
yeah,
All right. All right.
absolutely.
I'm
Yeah.
sure these guys will also want to hear like what. So you did your undergrad. Did you consider working in India? Go to some, or were we very clear as you were studying that what I want to go on to grad school? How did that decision come about?
Yeah. I mean, I think I was very interested in the area that I was working on. So I was studying in college in computer science, and I was interested in systems and database systems, a little bit of theory as well. I wasn't really sure whether I wanted to do more theory or more systems. There was always a question that was in the back of my head, and that will come back. That theme will keep coming back in my career over and over again. But um, I think I wasn't. I was enjoying studying, so it was fairly clear that I wanted to continue that. I think I wasn't quite sure if I wanted to do a master's or a PhD, but I think it was fairly clear that I wanted an opportunity to see a different world, to continue studying. I think I was in, and I think the opportunities in India at that time were much more limited. I think these days is a lot wider and broader. I think if you at that time, if you wanted to graduate, this was back in '95. The main opportunities you had was in consulting companies like Infosys and TCS and the likes of that. And it was interesting, but I think it wasn't as interesting that I had hoped for. So I think that plus the opportunity to just go to a different part of the world and learn and experience that, I think was very interesting. Plus, my brother was already in the U.S. He was in grad school at that time. So I think there was a sort of, it wasn't as foreign as maybe it might have seemed, because I had some family. I had one cousin, I had a brother who were already in the U.S. So it wasn't completely foreign.
Got it. So for those of the guys in the audience who are listening, what would you recommend? Any kind of guidance for them on? Let's say they aren't clear on what they want to do, right? So let's say they've gotten into mechanical or civil or some branch or any kind of subject area, any kind of the branch in their area within IIT. How do you think people can go about discovering what they're really interested in, what they're passionate
Yeah. I think the best way to do this is try it out. If you're happy doing what you're doing, then that's great. But if you have some sense of lack of satisfaction, you feel you're bored, try something new, right? So, try taking a class. One nice thing these days is, compared to at least 20 years ago, it was much harder to get online classes and online material. These days, you have amazing amount of resources online. So the cost of trying something new is very, very small. And I have some resources in my slides later on we can look at. I don't know all the course structure and class structure at IIT Palakkad. If there is a way for you to go sit in another class, you could just do that and try something that might pique your interest. If you want to, I mean, my background is computer science, so I can relate to that. It's easy to try a lot of online classes in computer science that are actually really good. Top-notch educators who put out all the class material out for free. And, it doesn't take a lot to just try it out and, try it out in the evening, see if you like that area, right? And especially if you're going to talk about AI, some of the things that I have are very, very easy to try out and see if that interests you. I think the most important advice I would have is, just kind of find something that you really enjoy doing. And if you enjoy what you're doing, that's great. Continue doing that. If you don't, find something that you think you will enjoy and just try it out for a little bit. And if you don't enjoy, fine, move on to something else. If you feel like you're starting to enjoy what you're trying new, then find more ways to do that, right? So don't get boxed into, your degree and classes is just sort of like one thing in life, right? Like, no, if you really look back 10, 15 years from where you are today, nobody will care about what discipline you started in. Think of it as a journey, right? Like you're going to have to learn new things in life all the time. And your learning doesn't stop with BTech. It doesn't stop with MS. It doesn't stop with a PhD. It doesn't stop when you're in companies. You always have to learn new things. So, even in AI, 5 years ago, very few people were doing AI, right? Including me. I didn't do a lot of AI 5 years ago. And you have to learn new things along the ways, right? And that's what I'm doing now as well. I'm learning a lot, actually. So find ways to learn new things all the time. And that's the best advice I can give you.
Okay, that's awesome. So I think that really sets us up for a little bit of a conversation around your grad school at Wisconsin. What do you think that experience was like? What did you like about it? What did you learn there? And how did that position you for getting into, kind of the next phase in your life with your career? How did that help you?
Yeah, so I think I was very interested in database systems towards the end of my undergrad time. We actually had a visiting faculty who was visiting IIT Madras at that time from the US, who was doing some research in database systems. I got the lucky opportunity to work with him in my final year in undergrad. He's now actually a faculty at IIT Bombay, Kriti Ramamridam. I don't know if some of you may know him. That got me interested in the area. So I continued that area in grad school in Wisconsin, which is one of the best schools for databases. And the atmosphere in grad school, I mean, there is no question that the United States has some of the best higher education systems in the world, right? So you saw that. I mean, IITs are great for many areas, but, amazing research actually happens a lot in US universities. So, and to be exposed to that, I think was really motivating and it was really wonderful for me. I think that experience was amazing. So I got to work with professors a little bit more closely. I got to understand what really sort of state-of-the-art, cutting-edge research looked like. And being able to do some amount of work in grad school doing that was really interesting, right? So, you're starting to move away from learning courses and doing projects to how do you start to think about building something new that hasn't been done before? And that's the main thing that you start to learn in graduate school is the idea of doing research. And research doesn't mean you have to have a PhD, by the way, right? PhD is sort of like one milestone in the career of somebody doing research. And by the way, I quit my PhD in the middle and I never came back to grad school. But I took a leave of absence. I went to IBM Almaden to do more research. And I never felt the need to go back to school and finish my PhD. I got a master's degree. But the idea of thinking about problems that haven't been solved, and how do you start making progress towards those problems, and how do you do that in a very diligent way is the art of learning how to do that is what I learned in graduate school over my few years at Wisconsin and later at IBM Research as well. And that's, I think, a really enjoyable process, right? You start to not just do things that have already been done before. You start to learn to do how to do things that have never been done before. And that's, I think, is the most interesting and fun part of being in grad school and working on cutting edge things.
Yeah, no, hey, that's really, really good points there. So, do you think the way you thought about research in grad school and approach research, has that changed in terms of how students today should be thinking about what research is and how research is done?
Yeah.
What's evolved in that area?
Yeah, I mean, I'll be honest. I didn't have a great sense for what doing research was when I was in undergrad. Maybe I got a tinge of it in my final year, especially when we had visiting faculty. But till then, I honestly didn't have a great sense of like what doing research really meant. I think while you are in the first few years of undergrad, you kind of learn, I think, the basics of a lot of things. In the classes teach you the basics of algorithms or data structures or certain fields, but I don't think you get an opportunity to do really cutting edge research. Maybe you do a little bit of it in the final year. At least that's how it was back in my days. I don't know if it is different now these days or not. One nice thing I think is that people learn computer science way back in high school, so maybe some things have changed. But I think independent of that, I think you have to experience it. I think you do experience that when you're in grad school to sort of know what does it mean to do new things, to do cutting edge research. I think the way it's changing now, I would say, especially in the area of AI, is the line is very, very blurry. So a lot of research actually happens these days in industrial labs. One trend that I've seen in the last 5 years, especially, is that many faculty actually who used to be at universities are now at industrial labs, right? Because one of the things you need for AI is lots of data, and some other companies where you get a lot of data is actually in many of the big companies. So there has been a trend more recently for faculty people to actually at least either spend part-time or even take a leave of absence for a few years and actually work in big industrial labs. And when you do that, I think there's sort of a big continuum from building products to doing applied research to doing fundamental research. And many people actually span the spectrum, right? So, and that's actually what I do. Most days, these days, the work that me and my teams do span the spectrum from doing research to taking specific problems that are problems for users on the community at Facebook and figuring out how to solve them, to actually building products that is coming out of that technology. So it's like a sort of big continuum along the way.
Yeah, that's really, really interesting. Yeah, I think we'll come back to this because I think, for the students today, as you see there, who are still early in their journey, right? Trying to make their way into the profession, trying to understand the ins and outs of the fundas, if you will, of whatever they think they're passionate about. What separates the good from the great, right? Is the essence for them. Like, what makes a great researcher versus somebody who's a good researcher? I think you hit a really important point when you said you started discovering really what research was after a few years. So anything you can share on that, we'll come back to that because I don't want to miss out on. There's a lot you have to share with these guys on AI and machine learning. So let's get to that topic, and then we'll handle this in the Q&A. So, can you, for the guys in the audience, just start with the very basics of what is AI and what is machine learning, and how is it separate from deep learning?
These words are, by the way, are all very interchangeable. People use them very liberally, so I wouldn't get too hung up on one versus the other. One broad way to think about it is AI is a very broad field. Machine learning, you can think of it as one area of it, but most of what happens these days, machine learning, AI, like people use them very interchangeably. So I wouldn't worry about the terminology difference too much. Deep learning is certainly one type of machine learning where you are building systems that learn from lots of data, and the architectures people use to learn are deep in the sense that there are many layers, and you have some input in one layer, and then you build intermediate layers that learn different representations along the way towards a final goal that you might have, which is to solve a specific problem like recognizing what's in an image or understanding the meaning of text, or taking audio forms and translating it to text, speech recognition, for example. So deep learning is just the fact that there are many layers. There's a certain types of architectures. There are many layers to the architecture, and intermediate layers learn increasingly complex, more higher level abstractions along the way of from the inputs to produce outputs, right? And the word deep learning is sort of been used a lot more recently in the last 5 years because that approach has proven to be very, very successful for many tasks, which were traditionally, the community didn't make a lot of progress in the last 20, 25 years. But in the last 5 years, there's just been a big revolution where these deep learning techniques have made huge advances in the areas of image recognition, speech recognition, language understanding, and areas like that. So that's why there is a lot of buzz around it these days.
Let's get a quick show of hands from the audience. What do you guys, who all there is interested in this area of AI and machine learning? Just raise your hand if you are. Okay, wonderful. There you go, Srinivas. You got a lot of guys there ready to jump in and give your team some competition. And
awesome.
There you go. So that's the kind of AI machine learning. Looks like these guys are interested. If they wanted to get started and learn more and more about AI and machine learning, you said you had a few resources. Can we bring that up? Maybe you can talk to that.
Okay. Yeah. Can you go to the last?
Is it in your presentation? Yeah.
Yeah.
Sure. Let me bring it up. There you go.
There we go. Yeah. I think the first one, sorry, I don't have links for 1 and 2, but you can easily Google it and find it. There is a very basic machine learning class by Andrew Engg on Coursera, one of the best introductions to machine learning that you will ever find. And many of you might have already done that. If you haven't done that, I would highly encourage you to do that. It's a very, very good course. Do the exercises. That's the most important thing. And other general advice I would give in all this is that, don't just be theoretical about it, right? Like the AI and machine learning these days is a very, very empirical field. The theory on this is surprisingly little, actually. And that's actually one of the criticisms also of this field these days, is that a lot of things work because people have tried it, but the underlying rationale and principles and theoretical foundations for deep learning especially is actually still very early and still forming. So the best thing you can do is actually try things and build things on your own to see what works and what doesn't work. So the practice is actually extremely important. So I would start with the first one. That's a very basic machine learning class. I think Andrew Ng also has a bunch of classes around specific areas of deep learning. I think he has 5 courses, if I remember right. There's one on computer vision, there's one on speech, there's one on language, there's one general deep learning class. It's a series of 4 or 5 classes on Coursera. I would highly encourage you all to do that as well. And they have exercises in each of them. I think that should give people a fairly good introduction to the field. I have a couple of books here, which is also pretty good to start with. Fast.ai is a site that does a lot of classes, online classes. It's very practical. I think that's also a pretty good resource. And then there's 2 big platforms that are used by many AI developers these days. One is TensorFlow and the other is PyTorch. One by Google, the other by Facebook. I have actually resources for both of them as well. And again, you'll find plenty of very good material in both those sites.
Yeah, that's quite a list there. Now, I think you had some interesting slides for us. So just so the students get a flavor for what does it mean? What are the benefits of all this technology, right? In terms of from a user point of view, I think that will really give them a feel for it. So should we run through that now?
Yeah. I'm just going to get a sense. How many of people use Facebook in the audience?
Yeah. How many of you guys are on Facebook?
Okay. Fair amount. Yeah. That's good.
Okay. And let's talk about other than Facebook. Do you guys use LinkedIn? People on LinkedIn? Some of you? Okay, got it. Looks like more Facebookers than LinkedIn. That's interesting. Maybe the right thing to do at your stage in life. That makes sense. All right, let's go back. And Srinivas, just let me know where to kind of.
I think I'll take 5 minutes to just go through the whole thing because it's good to give people a flavor for how AI is used.
Got it.
So, for many of you use Facebook, I'm just going to give examples of where AI is actually used at Facebook, so you can start to understand the practicalities of it. So I'm going to give you 4 major areas. These are things that my team works on too, in terms of technologies that we work on. One is computer vision, one is natural language understanding, one is speech, and the other is personalization. So let me give you examples of how technologies that we build in each of them is actually used in the company. Next slide. This is can people see the picture of dosas?
Yeah, yes, we can.
Yeah, so very simple. So let's say I post this is me and my friend. We are having dosa in one of the restaurants. But let's say many of my friends are interested in dosas, right? And they may want to know where are good restaurants to eat at. Now, computer vision can help me understand if there is dosa in the picture, right? And if I can detect that there is dosa in the picture, it can make sure that people who might be interested in dosas definitely see this picture. And then they might be able to know, what restaurants to try. It's a very simple example, but by understanding what's in an image, you can now help connect people with things that they're interested in, right? Maybe some people are interested in architecture, maybe some people are interested in birds. So if you can detect what's in an image, you can actually help people connect to things that might be interested in. That's a very simple example of how computer vision is used in Facebook. Next slide.
Yeah.
Actually, I'll skip this one. It's a little bit technical, so let's skip this.
Yeah. Okay, language understanding.
Yeah, so, if on Facebook we have 2 billion people, half of the people on Facebook don't speak English, right? That's not their native mother tongue or native language. And people use over 100 different languages. Let's go to the next slide. So translations is an example that we use to help connect people who speak very different languages. And maybe there is a person who speaks Malayalam and there's another person who doesn't understand Malayalam. If you can translate content from Malayalam to English or vice versa, you can actually help people communicate across language barriers. So we do that for over 2,500 language pairs, over 70 by 70 languages at Facebook. And we serve about 6 billion translations every day. So that's another example of how people are using translations and language technology to help connect people communicate across language barriers. Next slide. So this is Messenger on Facebook. I don't know if people use Messenger, maybe use WhatsApp, but on Messenger, here's two people talking to each other. And one of the things we do is, if you can understand the intent of people are trying to say, so here is somebody who's saying they're trying to say happy birthday and they're trying to meet each other. We can understand that the two people are trying to meet each other and we can suggest recommendations, right? So here's, we can understand language and understand intent and suggest more interesting things for them to do. So maybe you can pop up and say, hey, do you want to plan dinner? And here is a place that you might want to visit. So again, how language understanding can help connect people better. Next slide. This is an example of language understanding. So there was a big hurricane in Puerto Rico. Somebody went to help people there. And then they posted on their Facebook saying, hey, I'm going to Puerto Rico to help. Where are the areas that people need most help, right? And so a lot of people commented and then saying, we need help here, we need help here. And then we are able to understand the text and be able to extract what places people are actually talking about and populate it in a map, as you can see here. And that really helps relief workers who are helping with hurricane go to those right places and then offer relief and offer supplies for the people who are suffering from the hurricane impact of the hurricane, right? So again, very important example, very simple things that we can do by understanding language and by understanding and extracting entities from the text. You can populate a map and help direct people to go to the right places. Next slide. This is an example where we are using language to understand. So, a lot of people ask for blood donations on Facebook, but if you're able to understand the text and then be able to know that it's blood donation, the image is actually slightly wrong, so don't worry about the image. But the general principle applies here. So you can ask for blood donations, and then if you know that people are asking for blood donations, you can promote the post on Facebook. Here on the image, you can see that I'm promoting a certain charity, right? Again, you can help people who might be interested in donating to charity recognize that I'm asking for charitable giving and then promote the post. So again, simple examples where by understanding what I'm saying, we can actually connect people to people who might be interested in helping out. Let's go to the next slide. Yeah, let's go to speech. This is a new product that Facebook announced recently. It's called Portal. It's helping people connect to their friends and do better video calling. And one of the things you have on the device is a voice interface. So you can basically say, hey, Portal, call my friend Mani, right? And then it will recognize what I'm saying and basically start a video call with Mani, for example, in this case. Again, a simple example of how voice recognition and speech recognition is helping me do very simple things where I don't have to go to the device and type things and stuff. It's just a much more natural interface for humans to interact with technology. Let's go to the next one. The last area is personalization. Actually, can you go to the next one? Yeah, this is a Facebook newsfeed, and many of you who use Facebook probably see this, right? You see a lot of posts that are important and personalized to you. How does personalization happen? If let's say you have 100 friends or 200 friends, there's so much content that each of your friends are posting that you can't really see everything. You can only see certain relevant things. And there's an entire algorithm that decides what is most interesting and what is most relevant to you, right? And that system is actually all done through deep learning. It's done through a fairly sophisticated system that understands all the content that you have in your system, that understands what types of things that you've liked in the past. Maybe you see images of dosas that you might like them. So it really tries to match a lot of the content with what people are interested in, right? And that's actually done through AI and deep learning as well. And that's one of the most important applications that we have at the company. So hopefully that gives you all a flavor of how AI is used, right? And it's going to get even more important as we go in the future. That's recommendations of groups and pages. You can skip this one.
Okay.
Cool. You can skip that too. That's this. I put this link in the resources too.
Got it.
Yeah.
All right. So yeah, so I think we covered quite a bit there. So all very interesting topic areas. So it sounds like AI and machine learning is really trying to help us. I mean, there's traditional computer science and software and systems and databases and networks and all that, which is more structured, easier. But you guys are really dealing with a lot of the things that have been hard to solve in the past, right? The kind of the fuzzy stuff, the more difficult stuff when it comes to speech, when it comes to vision, when it comes to voice. A lot of these are newer application areas. Pretty exciting, actually. Can you say anything about the state of, say, virtual reality? I know it's kind of tangentially related, but
I worked on it for 2 years, so I can definitely talk about it.
Okay, there you go. I just hit on that. That's good. Okay.
Yeah, I worked on Oculus for 2 years. I think it's a very interesting area. I think there's a bunch of interesting products that are out there in the field from Oculus and from other companies. It's a great immersive experience for people who like gaming. It's actually fantastic. You are completely immersed in a new area, and you almost feel like you're there. And I think that's a pretty substantial step forward from what previous generations of technology have helped you achieve, right? Which is a sense of immersion that you almost feel like you're there. And that happens because we are able to completely understand your movements and track you in a space and be able to use that to localize the content and adapt the content, right? So that level of immersion is pretty amazing. Now, what you can do with it, I think the initial applications have started in gaming and very immersive entertainment. People do 360 videos, so it kind of gives you a sense of you almost being at a new place. But the technology is still very early. We still have a long way to go. The headsets that we have are a little bit cumbersome. They have to be tied to PCs if you want to get very high fidelity, high quality VR. You do have mobile virtual reality as well, but it doesn't give you full immersion, and it's not at the same level of fidelity and quality that you get with PC headsets. So the field has a long way to go, in terms of ease of use, in terms of simpler form factors, not being bulky, not having to be tied to a PC, so you can actually walk around more easily. And applications also have to grow a lot. So it's actually a very exciting and active area of work. And I think you're going to see a lot of progress in the next 5 to 10 years. Another area people are working on is augmented reality. Virtual reality is completely immersive, but augmented reality is, can you actually augment the world around you? If I'm watching something, can I actually create virtual objects in front of me? Let's say you are sitting in a class and you want to play chess with somebody who's not nearby, who's maybe in a different city. Why do you have to go online and do all that, right? Like maybe you just put a glass on and both can see the same chessboard in front of you, and you can start making moves, right? So that would be pretty cool if you could do that. So this idea of augmented reality, where you can just add virtual objects no matter where you are and actually interact with each other. And I think that's actually also an active area of research. And I think you're going to see a lot of progress on that as well in the next 5 to 10 years.
Yeah, it's funny because this good friend of mine, she jokes that she wants augmented reality. So when she's at a party about to meet someone and she doesn't know who they are,
yeah, absolutely. Yeah.
Look them up and have their name pop up, and then she can say, "Hi, so and so,"
yeah.
Feel good about they know her or she knows them. So let me ask the guys in the audience, anybody there, have you ever experienced, had a virtual reality experience where you've looked at any 3D videos on YouTube using those VR glasses? Anybody? Raise your hand if you have. All right, so I'm sure you kind of know what that's like. I saw, believe it or not, I finally had my first VR experience last year, and I was here at a charity event where they had used Google VR videos. They had actually teamed up with Google and filmed in 3D video certain classroom experiences for rural kids across India. And so what was cool about it was, here I was sitting in the Bay Area, and I put on those VR glasses, and I felt like I was in the classroom with them in India. I felt like I was, standing on the road in rural Andhra Pradesh, right, watching those bullock carts go by. So I think you're absolutely right. This is going to completely transform the kind of emotional immersion, and it has much wider application that I think any of us is, maybe even thought about. So let's move on. I know it's, we already at the 25-30 minute mark. We should probably wrap up another 15-20 minutes. So I'm going to now turn it over for Q&A to the students, and I think Dr. Mrinal, you were going to come in and moderate some of this discussion.
I'll just hand over the session soon to Mrinal. So maybe Shall I ask one question to begin with?
Please do.
Yeah. So it seems like your team in Facebook is doing AI, applied machine learning in a lot of different areas like vision, language, as you were telling, right? Vision, language, speech. So the domains are very different. So how similar are the techniques that you apply? I mean, why I want to ask this is because as per our new curriculums, the student starts learning some sort of AI courses starting from their 5th semester. And then they also have this opportunity to do some electives. And also, I'm sure they do a lot of online courses. So, and when they are in a stage when they choose their final year project or things like that, with what they learn, that may not be the entire set of techniques, right? Which the techniques that they learn, how much will they be able to apply, and how broad is the domain in which they can apply what they learned?
Yeah.
Very good question.
Yeah, it's a really good question. I think what is happening is that, especially 5 years ago, these domains were way more different and much more specialized. What has happened in the last 5 years is that the techniques people use, whether it's vision or language or speech, there's a core set of techniques that are actually fairly common. People use, and especially all these fields are starting to use deep learning in a much bigger way. The core set of techniques you use in deep learning, you build deep architectures, you use convolutional neural nets, you use recurrent neural nets, and these sort of principles are pretty similar in many of these areas. So I would say there's a base set of techniques that you should just learn that might be applicable in any of these domains. How to build convolutional neural nets, how to build recurrent neural nets, and those are some of the core architectures and just like general deep learning techniques that is common across all these areas. But after a certain point, you ends up being specialized because the specific problems you need to immerse yourself in the domain a lot more. And that's what I've seen typically happen is that some people can interchange between domains a lot because a lot of the techniques are increasingly getting similar. But there's also a good amount of specialization that happens where people immerse themselves a lot in certain areas. And then even if you use similar techniques, you have to adapt it and apply it in very specialized ways in those domains. So I would encourage your curriculum. Sorry, go ahead.
Now, I was just going to ask you, can you elaborate a little bit on which of these resources actually highlights these core techniques that you're talking about? I know you
They
mentioned a
all
couple.
do, actually. If you look at, I mean, they all do. I think the ML class is just very general machine learning. That's like basic foundations. You need to do that before you do anything with deep learning and AI. The deep learning courses on Andrew Ng actually go into each of these domains. He has a computer vision class, NLP class, a speech class. But the techniques you learn are actually, some of them are very common, right? Use recurrent neural nets, whether in NLP or in speech, for example. Use convolutional neural nets in vision as well as in speech, actually even in NLP in some areas, right? So a lot of the core techniques are same, but some things do vary. So my suggestion and advice, if you're building curriculum, would be, look at a lot of common things and build them in a common curriculum. And you can build as a generic deep learning techniques as one part of the curriculum. And then once people have that, you can have a more specialized class, whether it's in speech or vision or NLP as well.
Yeah, thank you for your very explanatory answer. So now I invite Mrinal to take charge of the remaining question and answer session. Thank you.
Thank you, Dr. Jasdeep.
Hi, Srinivas. So we have some questions from the students. Lekkala Madhu.
You can go ahead and
Okay,
pose
so
it.
I'll read the question for him. So the question is, having several years of experience in industry and life in general, if you were given a chance to a final year BTech student now, what would be your career choice? Higher studies, industry, or anything else?
So the question is, if I were to do if I'm in my final year now, what would I pick? Higher studies, industry, or
anything else?
I would still do higher studies, no question. For me personally.
Can you please give some motivation why you would like to choose that?
I think so. If you enjoy what you're doing, I think there is a lot more to learn. And I think a couple of years, actually, one thing I will say this, maybe it's not very obvious when you are in grad school or even in undergrad, is that 1 or 2 years doesn't really matter a lot in the grand scheme of things in life. Sometimes I felt this myself when I was in college and when I was in my master's program. To actually have maybe a rush to go and work and make money. And when I think back, it's like, that just didn't make a lot of sense. 1 year, 2 years doesn't make a lot of difference in the grand scheme of things in life, right? So for me, what you get as a student is this amazing opportunity to be full-time dedicated to learning. Once you start working, you have an obligation to actually produce something for the company you're working, right? So while you learn something on the job, you're also like on the hook for delivering certain things. Somebody's is paying you, which means you have to build certain things that is important for the company. So you're not 100% focused on learning, right? So if you want to learn more in a certain field, the best way at very early in your career is to dedicate completely to yourself to doing that. And that's one. The second is, being in an environment, IITs are amazing. And, for higher learning, I think finding places to do that really well, I think is excellent. You would get exposed to a different set of people, a different environment. So for me, I think that's really valuable. So I would definitely do that again.
If I can add a couple of things, I believe, as Srinivas said, getting a master's degree from a top-tier U.S. university puts you on a very different career track, and really positions you for much bigger jobs. Looking ahead, you'll more than make up for the 2 years that you might commit or make an investment, right, in a grad degree. Now, here's one thing that you guys have as an opportunity that we didn't, which is, if you have a lot of financial pressure because of which you do need to go and work, here's the good news. Now, there's several of the top 10 programs, computer science schools are starting to open up online degrees. You can actually do a part-time online degree while you have a job. Might be over a longer period of time, might be over 3 years. Get your 30 credits, and it's very cost-effective. I mean, I know about Georgia Tech. I think it's like $10,000 for 2 years. Might be a year. It's 20,000 total. UT Austin is actually kicking off an online program for masters in computer science, and they're going to be accepting students from around the world. You could be in India in a job in Bangalore or Chennai or wherever, and you could be taking a part-time online degree program from a top-tier U.S. university. All you got to do is do a GREs and get accepted, and there you go. So I think opportunities are amazing for you guys, kind of where you're at and kind of at this stage. Dr. Mrinal, back to you.
Okay, so I'll go to the next question. Do you feel that the field of CS is too much coiled around data science today? What are the other interesting and trending areas in computer science as of now, if any?
Yeah, I think there's definitely a lot of focus on data and science, but I don't think that's definitely the only area. I mean, there's plenty of interesting work happening in, I would say AI is even orthogonal to data science, right? So yes, it uses a lot of data, but it's sort of a separate field by itself. I mean, systems and infrastructure is still really important. And just learning how to build practical systems, right? So even in a lot of AI, it's not just pure science. You have to engineer a lot of things. And having a really, really good systems background is extremely important for doing that. So systems, I think, is like systems and infrastructure is a really important area. I think what else? Programming languages. I think there's always interesting evolutions in these areas. I think it kind of matters. I wouldn't over focus on any one specific area. Find any area that you find interesting. There is always plenty of interesting work going on in there. Networking, there's a lot of interesting stuff happening, especially with mobile devices and other things. Human-computer interaction, robotics. All these are really interesting areas, right? So I think computer science in general and technology in general has evolved a lot. Graphics, I think, is really interesting, especially with VR and AR. There's plenty of interesting problems to solve there. I don't think there is any one area. There is a lot of interesting work happening across the board.
Okay, so you have one student here.
Good evening, sir. I'm Jufel, studying second year electrical engineering. So my question is, like, I'm in electrical engineering, but I do want to step into machine learning and deep learning. Like, I'm currently doing the courses you have told me. So what is our scope? Like, what is the scope of AI in electrical engineering? That's what I wanted to ask.
I think I would not worry as much about the degree that you have, whether it's CSE or CS. Find the learn what you want to learn, right? At the end of the day, a course and the degree is just like a label. Nobody actually worries that much once you have started working and once you're doing higher studies, whether you had a EE degree or whether you had a CS degree, it doesn't matter as much. If you're interested in machine learning and AI, I'm glad that you're doing the courses that I've suggested. And if that area of work is really interesting to you, I'll try to find more ways to do the same thing that I've said. Go deeper in many of these areas, right? And I would also apply on to higher studies in that area. Find maybe CS courses that you can do in this area. I think there is actually plenty of opportunity at the intersection of AI and EE, which especially in robotics. You have to build electrical systems, you have to build mechanical systems. They all have to have an understanding of the world and computer vision and other things. So robotics might be an interesting area that is at the intersection of EE, mech, and CS. So if that's an avenue for you to explore, you might want to explore that. But I'm just saying, like I said, if you're continuing doing the courses, continue doing them, apply to higher studies, and don't be too worried about the branding, whether you're EE or CS. At the end of the day, that's just a name. Nobody really cares as much, right? So And be fluid about your own identity. Don't worry about you're a CE guy or you're a CS guy. It doesn't matter, right? You're just a technologist at some point. And find ways to explore things at the intersection that might be interesting as well, like I said, like robotics or other areas.
Thank you, sir.
Okay, so I'll ask the next question on behalf of the students. So from the recruiter's point of view, as in Facebook, what are the skills do you think are important if they want to get a job in Facebook?
So I don't know how our university recruiting is these days, but I think we probably still recruit some amount. The most important thing is to be able to. I would look for generally two things to be really good at. During the interview process, you're going to get asked various questions on algorithms or coding, and you have to solve them really well, right? And that comes from practice and from trying out questions offline. There's probably plenty of online material for how to do coding interviews really well. So I would suggest practicing some of that. The second is genuine interest in side projects. So people like seeing something in your resume that shows that you have done something over and beyond just like taking classes in college, right? So show examples of things you have done by yourself, that you have taken initiative and you have tried something, whether you have built something on the side, whether it's an app, whether it's a robotics kit, whatever you have done that really shows your personal passion and you have something that you're able to produce, right? So I think examples of those I also think are really helpful. And I think that doing those on your side also helps you get interested in and helps you understand what is it that you're really finally interested in. So side projects and learn how to do coding really well. And I think that's the other advice I would give you for all of you is be very practical and know how to actually get things done, right? So practice writing code, practice actually building things, being hands-on, and doing lots of things that are very practical in nature. And that's sort of what people look for when you go to the industry.
So regarding the coding, I would like to ask a little bit more. So do you think the solving little bit harder problem with a little bit more time is better, or some simpler problem with a quick solution is better? Which one should be having the more focus from the student's point of view?
I think that's a hard question to answer. I mean, at the end of the day, it's very hard to know what type of questions you'll get asked in interviews. So you should probably be able to do both. And basically, given a question, you should be able to answer it really well and able to write code that shows that you can answer it well. So I think speed matters only up to a certain degree. You don't have to solve questions in 2 minutes or something. Like, it's not like generally interviews last for probably around 30, 45 minutes. So you need to be able to solve maybe a few questions in that time frame. But if you can solve simple questions in 10 or 15 minutes, that's probably fine. So if you can solve complicated questions in half an hour, that's probably fine, right? So don't try to optimize between 2 minutes and 5 minutes, right? Like that doesn't really matter. Think of it as like you're going to probably have an interview that lasts maybe 45 minutes. And if somebody asks you to reverse a linked list, you shouldn't take 45 minutes to do that. You should be able to do that probably in 10 minutes or 15 minutes. But if somebody asks you a much harder question, you might want to take a little bit more time, and that's fine. At the end of the day, your problem-solving ability is the most important thing, at least in interviews.
Sorry, I didn't mean to interrupt you, Srinivas, but yeah, what I've heard from my friends is first, the good news is that technical recruiting is becoming more objective. It's not subjective; it's objective. Second thing is critical thinking, right? I think that's what Srinivas was talking about, problem-solving skills. They're trying to assess how good you are at critical thinking, right? More so than did you get the answer right is, can you do it? Can you do it fast? Can you do it reasonably fast? And can you think it through? And also be articulate. As you're thinking, explain what you're thinking, explain your approach. That's the other thing in an interview, whether it's a phone interview, whether it's a live interview, that what I've heard is people expect that. And of course, you can go into Quora. Quora has a ton of things that people are answering about how to do, interviews, technical interviews. So I think, Dr. Manal, we should probably begin to wrap up here. So is there a final question that...
Yeah, I will double down on what Mani said. Explain your thought process in interviews. Don't just get the final answer is the least interesting thing of the whole thing. How you got there is probably the most important thing. So don't worry, just talk loudly about, hey, okay, here's how I'm thinking about the problem. Here's what I'm trying to do. and explain your thought process. I think that's really important.
So, Dr.
Any other
Manal, do you feel we can start to wrap up?
Yeah, sure. Thank you.
Any other final questions from the
We don't
students?
have any question from here from the students, so
Okay.
maybe we can wrap up.
Okay, so Srinivas, any final closing thoughts? I mean, how do you anything about for these students about how can they get ahead in career and life? Let's close on that note.
There are no shortcuts in life. You have to work hard. So work hard.
Yeah.
Find something that you enjoy doing. I think that's the other thing. And if you're not happy with doing something now, just try something else, right? And the cost of trying is actually very small. There are lots of online classes. Try something for a few months, see if you enjoy what you're doing. If you don't enjoy it, try something else. And once you enjoy a field, go at it full steam, right? Like there's a lot to learn in every field. And the other thing I would say is trends will change a lot. Something will be very hot right now. Don't jump into a field just because it's hot right now, right? Like things always change. Nobody was talking about AI 5 years ago, and now all of a sudden AI is the big thing. And I happen to enjoy AI, so it's good for me. But I wasn't doing AI 5 years ago, right? But I was doing other things that were still important and interesting, like database systems and other things. So something or the other will always be interesting. Find something that you enjoy at the end of the day, and be open. Always be learning. I think that's the most important thing. Learning never stops in life. Don't think that after 4 years you're done learning. You have to keep learning all the time.
On that note, that's a very good closing thought. Keep learning all the time. We'll wrap up this video chat interview. Thanks, Srinivas. Thank you, Dr. Manal, and thank you, students, for coming and joining us today. Have a great rest of your day.
Thank you, everyone. Really enjoyed talking to you all, and good luck in your life and studies and career.
Thanks, Srinivas. Bye-bye.
Thank you. Yeah.